What is diagenesis in taphonomy research? Imagine finding a fossil and wondering how much of what you see is original and how much has changed over time. That's where diagenesis comes into play. It is the process that happens after an organism dies and gets buried, transforming its remains through physical, chemical, and biological changes. In taphonomy, which studies how organisms become fossils, diagenesis is the last step in the journey from life to fossil record. When an organism dies, its remains don't just stay the same. They can undergo mineralization, where minerals from surrounding sediments replace organic materials. For example, bones might become filled with minerals like calcium carbonate or silica, which preserve their shape but change their composition. Sometimes, chemical reactions cause parts of the remains to break down or alter. Collagen in bones, which is a protein, can hydrolyze or break apart due to water exposure, affecting how well the fossil retains original biological information. Environmental factors play a big role in diagenesis. The chemistry of the sediment, like pH levels, can influence mineral replacement or dissolution. Groundwater movement can carry minerals into or out of the remains, changing their structure. Temperature also matters. Higher temperatures can speed up chemical reactions, leading to more extensive changes. Microbial activity is another factor. Microbes can break down organic materials or produce chemicals that alter the remains. In paleoanthropology and biological anthropology, understanding diagenesis helps scientists interpret fossils correctly. It allows them to tell whether changes in the fossils are from natural post-burial processes or from human activity or environmental conditions at the time of burial. For instance, if a fossil shows signs of mineral replacement, researchers can determine if it's a natural part of fossilization or if it was affected by later processes. Knowing about diagenesis also helps in choosing the best fossils for detailed studies. If a fossil has undergone minimal diagenetic change, it might be better for analyzing ancient DNA or isotopic compositions. It also helps reconstruct the environment where the organism was buried, giving clues about ancient climates and ecosystems. In essence, diagenesis is the series of physical, chemical, and biological changes that organic remains experience after death and burial. It shapes how fossils look today and what information they can tell us about past life and environments. Recognizing these changes is key for scientists working to piece together human evolution and the history of life on Earth.